physicist with Atlas Experiment, CERN, Stephen Goldfarb. Stephen, welcome back.
Thank you. It's great to be back.
Yeah, back to your hometown.
Yeah, it's good to see Jackson. It looks good out there. All these paintings all over the place. I follow on your Instagram to see what's going on.
Oh, thanks.
And I noticed when they put up these new paintings, and even one inside your studio here.
We're very proud of that, by Jackson's own Zack Snyder.
Mm-hmm.
Jackson, I think, is appreciated most by people who have been away for a while, because we've seen the changes, but we don't see the contrast from then to now.
Yeah.
You do.
Yeah, and it has advanced. It's great to see. I mean, I remember growing up here, and we all wanted to be one of these astronauts. We had a lot of astronauts early on.
Yes.
I think we had the most astronauts, and I always thought, well, they're just trying to get as far away as possible. That's all. but in the end, it's a great place to come back to. It really is.
That's not why they became astronauts.
No, it's okay. There's some other appeal to it.
Yes, and they did come back.
Yeah.
Not permanently, but.
Yeah.
And I'm glad you come back. I think one of the neatest things about you is the experience that you've gathered by all your world travel and all the experiments and the work that you're doing at Atlas Experiment, CERN. Mm-hmm. One of your challenges is, I think, and every time you're here, I ask the same question: what do you do?
What do I do? I do research. It's fantastic. It's a laboratory that was built after World War II, CERN, the entire laboratory, and there's many different experiments there. And it was built to bring people together from all over Europe where there had been war. They've been trying to build better weapons, and scientists don't really like to do that. So they got together to do research, nuclear research, which then became atomic research, and went further in until we got to protons and to quarks, and we just keep going.
Was it because of the war that this was created?
I think it was the aftermath. It was around 1954, and they wanted really to get the scientists to work together towards peace. In fact, that's written in the charter. We're doing science for peaceful purposes. But there is this natural need for humanity to do fundamental research to try to understand our universe. And so we're going to do it one way or the other, and might as well put us together in a lab where we can do it efficiently and effectively, and it's been incredible.
Well, I'm glad that you do it and represent Jackson in this great project. Mm-hmm. You brought some photos. We're going to go through and take a look at some of what you've been up to, because there's a couple crazy ones.
Yeah, there's a few. This is one of my favorites. It's an artist rendition, mind you. In the background is our detector. It's the largest particle physics detector in the world. It's something like a quarter of a football field in height and half a football field in length.
Underground.
Underground. It's a full 100 meters, 100 yards or so underground. Wow. We can't basically afford the land above. It's Geneva, and the accelerator is 27 kilometers or 17 miles around. So we need to dig that underground, and they love digging there anyway. The Swiss and the French have tunnels everywhere. Yeah. So that's great, and so that's the detector where I work. I love going in there. I like to go in there because I can walk around and do visits. I do virtual visits. By the way, if anybody contacts me, that's a fun way for a classroom to actually see this. I walk them around and show it to them.
Literally, physically, you walk them around.
I walk around, and I have my phone.
They're somewhere else,
and I show them. But the image,
because it's tight. You can't. I saw you snagged your sweater on some zip ties down there.
Oh yeah, you can easily. There's a lot of zip ties. I mean, we have like 120 million channels of information. So there's cables everywhere. I love looking at all the cabling, knowing that this is such a human endeavor. Here you can see, I mean, we've been doing many things. I came on here several times and talked to you about the Higgs boson, this discovery that we did. It's been 12 years, believe it or not, since we discovered that, which was a particle which told us how other particles get their mass.
I thought your job was ended. It was going to end when you
when we did that, but there's so much more. So that last picture was about something that they found really we weren't expecting. It's called quantum entanglement. And that meant that we found out that these particles that came out, there's these top quarks, and we sort of, this is an artist's rendition of it. They're entangled, so when you measure one, you affect the other one instantly, which is something which we're trying to exploit all over the world for quantum computing and various things. In fact, next year is going to be the International Year of Quantum. Apparently the UN declared that.
Okay.
and they'd have to tell all the particles about that, but it's amazing. So we actually got a glimpse of it in our detector.
Next.
Next,
We're
we're going to have a physics lesson here. We're going to go through. This is a really cool experiment. There's besides the Large Hadron Collider, this enormous collider that I work on the ATLAS experiment.
By the way, in high school, I took physics for 2 years, and I remember Terry Dangler was my physics teacher, and that's all I remember.
Okay, I had Mr. Nearpass was his name.
Mr. Nearpass,
and
Dave Nearpass?
Yeah, Dan Nearpass. He was fantastic. I loved it, and it was really inspirational. I mean, the teachers here are heroes, really.
Do you think that your experience in Mr. Nearpass's class forged your future?
I think it made a big difference. I think it was very important. He was excellent. He talked to us whenever we wanted to talk to him. And I think between him and also seeing the astronauts at the time got me interested in science. It took some time before I decided exactly which field. But when I went over and went to CERN, I saw, here I am with people who are from all over the world and who are so smart. They're all smarter than I am. It's fantastic. That's the best place to be.
Everyone's smart. Everyone's smart.
They're all smart. The last picture I should tell you is an experiment is done. There's an antimatter facility. So they can actually produce, we can not just make antiprotons, we knew how to do that for some time, but we can take and put positrons, which are anti-electrons around them. You can't touch this, right, because it will annihilate, but you can use magnetic fields to hold it together. They now can really capture it and hold it. This was a study to see if antimatter falls up or down.
Huh.
So a very, very basic principle.
I'm going to guess.
Yeah?
Up.
That would be really cool. So far, though, the first evidence, so it's only like 3 sigma, shows that it falls down. And most of us sort of expect that. There's nothing in the models that tell us it should fall up, but you've got to measure it. We don't believe anything. So there's still have a chance. You still have a chance to be right.
Okay.
There will be more precise measurements in the future.
Keep studying. All right, another picture with words in it, which
with words and
very
code,
helpful to me.
with code in it.
Code.
So this is just to advertise, a shameless advertisement here, that the coffee's great. First of all, that's important to advertise. And also, we have data which we're giving out to the world. It's open data. Before we had given some out to schools so that they could play with it and they could learn real data from the experiments, and they could use our tools to do analyses and to try to find the things we had found. Now we're actually giving out huge amounts of data so that they can really do physics if they want to with this. And we do this, and I should also mention that the other experiments are doing this as well, because I want to be fair to them. CMS is sort of our partner and our competitor across the way in the accelerator, and they're also doing this as well. And it's fantastic because people have a chance to actually use real data.
Collaboration, it's all about that, and you have people from all over the world
Yes.
that are working on this.
That's what's so cool, and I love that about this. So this, I often show, there's a picture we show which doesn't have as many countries in it. It shows the countries which have institutions on the experiment. This one I think is the best. This shows that you have people from all over the world. These are the nationalities. These are the passports that are at CERN, where we have, in our experiment, we have almost 6,000 people in the experiment itself. So there's other experiments as well, and they come from 103 different countries. And that experience, I wish everybody could have that experience, because to work with people of different cultures, different social backgrounds, different linguistic backgrounds, everything is so important for science, because it means that everyone has a different idea, different points of view on how to solve a problem. And science itself fundamentally is different people measuring the same thing over and over again, and then saying, yeah, we agree, this is what we know. That's what science is. And so it's essential to it, and it's fantastic. It's great.
You've got not just people collaborating from all over the world, but students are coming in from all over, including from Ann Arbor.
Yes.
And Ukraine.
Yeah, this is another half of my life outside of the research. So I work for the University of Melbourne for research, but for the University of Michigan, I've continued to help them to run their student programs. And we were bringing in students in the summer. We have students selected from all around the country, the smartest students. Don't tell them I said that, but the smartest students. And we select them, they come for the summer. And we have students from the University of Michigan who come for the summer. But recently, the State Department gave us some funding for Ukrainian students. And actually, if I can show you that picture again, there's something that's really heartwarming in it for me. First, heart chilling. So if you look at the upper left there, you'll see that there was, this was going to be a classroom that held a master class that we were going to hold in 2021. That's where you get high school students, they come in, they learn about particle physics, and then they get to play with some real data and learn some things. That happened, perhaps fortunately, a week beforehand, the place was shelled.
Oh my.
So they didn't hold the master class, and I told them, whenever you're going to hold it again, let me know. And the next year, we got some funding from Michigan. We got some Ukrainian students out. And these students were fantastic. They came, they're undergraduate students. They did research, very bright. And they then, I had them come and do, from our experiment, to do a video conference with the classroom in Kharkiv, where the professor had found a safe place for them to do their master classes. He was not going to let this stop the students from learning. So we did those, and then if you look at the upper right, you'll see now we have students coming in. There's a mix of American and Ukrainian students there, all hugging each other. That's really heartwarming to me. And a new student who came in this last year, and I have 4 more who are going to be coming in January.
That's cool.
That's really nice. It's fun.
Those kids, their homes are being bombed, their relatives are being killed, but there's still life.
There's life has to go on, and these students, they're going to be rebuilding the country soon, I hope. And so they have the chance to influence that and to help them out. We're trying to get some of them in, actually a lot of them went into graduate schools outside of the country now. And they will go back. They're all want to go back when there's peace to help out.
All right, I think we have a couple more photos.
A few more things that a lot of things happen. It's been a while since I was here. This is my good friend Al Gore, although he always forgets to text me when he's in town. But he came by and gave us a lecture. And
Al Gore?
Al Gore. You ever remember him?
I remember. He was vice president once.
He was very close to being a chat or two away from being a president. He gave us this nice lecture which showed us the very clear evidence about how CO2 in the atmosphere is causing this global warming, this phenomena that we're seeing, which is really affecting the climate everywhere. Even, I mean, the super cold weather we get here is a part of that. And it was just, but there was optimism. So that's what I really liked. I was thinking, oh no, we're going to hear how horrible things are and that it's getting worse, and it is getting worse. But he showed that we have a chance, and that if we stop, if we can manage to get carbon neutral quickly, the newest projections are that it will start cooling down within years. It's not going to be, we won't have to wait a whole century, but it will start happening pretty recently. So we just have to
That is good news. A lot of people feel like it's too late.
I've heard that a lot too. It's good to know that there's still optimism in this.
Now you're also entertaining. You've got a band. It's a new name. It's the Canettes Blues Band. What are the Canettes? Canettes?
Okay, so we've been around now. I was just remembering we celebrated CERN's 70th anniversary, and I remember that we put the band together for the 40th anniversary. so we've been around a long time.
Okay.
A canette is if you have a big beer mug, a big beer, only really in Geneva, it's called a canette. In other places, a can is a canette, is a name for a can. But that's where it was to make fun of another band that we called it the Canettes, and it's stuck. But they're great, and they're getting younger. I'm the oldest one now. I was the youngest when I started. And now we've got a lot of young.
One more picture. You were arrested in Switzerland.
Terribly embarrassing. I don't know how you got this, but This was a lot. So my friend who's got his hands up against the car there, Irwin, he's a beam scientist. He works on the isolde experiments. They work on isotopes. And he went and bought this car. It's an exact replica of the Bluesmobile. Got it in Cincinnati, drove it around Chicago, took pictures, brought it over, and we were going to a movie. They were opening a new cinema, really nice, not actually an old cinema that had been redone. Beautiful place. They were showing the Blues Brothers movie. And so we brought his car and we were driving. And apparently not all of the police had been informed that we were going to be around. And so they were really nice. They checked, talked to all their friends, found out about it, and then I asked them if they could please arrest us just for,
Just for to be able to use a picture
A lot of fun.
back in America.
Yes.
We appreciate you taking time to stop by and give us an update on everything happening.
Well, it's great to see you. I have a little something for you because I hear that it gets cold here, although, nice balmy
will.
day like today.
We were talking before the show, we're in a bit of a warm
So
spell.
I don't want you to get too
That's
cold out
nice.
there. That's from our experiments.
I'll put it to good use.
Good.
Are there protons in here?
Quite a few.
Quite a few.
Actually.
Okay. All right. Thanks, Steve. Merry Christmas, Happy Holidays.
Well, same to you. Thank you very much.
You
Pleasure
bet.
to be here, Bart.
Our smartest guest ever, physicist Steve Goldfarb.